This is AP Calculus Lesson 10-5 or 10.5. Ooh, there, I can see it now. So the 3D printer is going in the background. I apologize up front. Let's go through this. So we have this graph. We're finding g of 6, g prime of 6, and g double prime of 6. So g of 6, what does that mean? That means I'm plugging in 6 into all the x's here. That means this is going to be equal to, I'm going to rewrite this, 5 plus the integral between 6 and 6. And I can just stop right there if I wanted to, because I know integral of 6 to 6 is just going to be 0. But I'll just, for the sake of being technical, I'll write this out. And I know that's just going to be 5 because integral between the same number and same number is 0. So this is 5 plus 0, which is just 5. All right, g prime of 6. G prime of 6, so by the way, g prime of x, before we even get to g prime of 6, means I'm taking the derivative of g prime of x means I'm taking the derivative of this thing and the derivative of this thing. Derivative of 5 is 0, derivative of this thing, we're using our fundamental theorem of calculus, and that's just going to be f of x. So that means I'm looking at the height at whatever point I'm looking for. I'm looking for the height at 6. The height at 6 is 3 right there, so the answer is 3. And finally, g double prime of 6, that is now going to be f prime of 6. I'm looking at the slope at 6, and it defines that for us. It says that it has a horizontal tangent at x equals 6, which means this is 0. Questions on part A?
No.
Perfect.
I feel like I was thinking too much about it, like of the f prime of 6, so I couldn't figure out what to do. But I'm good, and that makes total sense.
Perfect, okay. On to part B. On what intervals is g decreasing? So, definition of g decreasing is what, girls?
F prime is less than 0.
So, we'll say g prime
Sorry,
is
g
less than
prime
0.
is less than 0.
I know, it normally is an f. So, g prime is less than 0. We know g prime is f, so we're really looking for where is f less than 0. And f is less than 0 right there and right there. So, how do we say that in our notation? We say g is decreasing on -3 to 0, yep, and 12 to 15. And then we need to justify our answer. That's not enough. And we'll say because, and we'll use this definition. G prime is less than 0. G prime is less than 0 on those intervals. Perfect. Questions on B?
Did you say intervals?
I might have said integrals. I meant to say intervals, as I wrote. Yeah. Sorry about that. Okay. And on to part C. What intervals is the graph G concave down? Okay, concave down. G concave down. I cannot spell to save my life. There we go. Concave down. What is the definition?
G double prime is less than 0.
Yep, there it is. G double prime less than 0. That means we're looking for where f prime is less than 0. Where is the slope less than 0? Where is the slope negative? And it's negative all the way over there, and it never hits 0, so it's just one giant interval. So we say G is concave down on the interval 6 to 15. 6 to 15. And we have this for our rationale. G double prime is less than 0. So because G double prime is less than 0 on that interval. Questions on C?
Do we have to say on that interval?
You do not, but it makes it sound more professional.
Takes up like 10 seconds of our AP time.
Okay, yeah, then skip it if you feel like you're stressed on time. On to the next part of 10.5. So we have this function, and it's basically the same as 10.6, or the last problem on 10.5, but a new little graph. So g of 3 means we are going to be looking at plugging this in. It's going to be the integral between 2, and I'm plugging in 3 for x, so it's 2 to 3 of f of t dt. And instead of the same number to the same number, I actually have to find this area. So I'm looking for these areas right here. So between 2 and 3 obviously is between here and here, and I divide it up into one rectangle, one triangle. This rectangle is a 1 by 2 area of 2. This rectangle is 1 by 2 divided by 2, so that's 1/2 or 0.5 if you choose 0.5. So if I add those up, I get 2.5. Let's find g prime of 3. Again, similar to the last problem, g prime of 3 is going to be the same as f of 3. F of 3 means height at 3. Height at 3 is this height over here, which comes to 2. Yes.
Is it the area of the triangle? Sorry, on the last one?
Oh, it is 1. Yeah, that's an extra credit point. I don't know what I was... Yeah. It's 2 by 1, so half of 2. It should be 1. Thank you. Okay, let's just go like this. Grab all of that and undo those, and then I will redraw that really quickly. That's an area of 2, that's an area of 1 for that triangle. Which means that this stuff is... No. That stuff is 3. Thank you for the catch. Alright, and then, yeah, f of 3 is 2. We're good with that. No errors on Mr. Sindell's part quite so far. And then g double prime of 3. That's going to be the same as f prime of 3. So what is the slope at 3? So you can just kind of look by this graph. It doesn't change. This goes down 2, right 1, so it's a slope of negative 2. Do we need to review how to find slope? No, we're good. All right. And then on to the final part, part B, inflection point. So inflection point at x is equal to, well, what is the definition of inflection point again?
It's like
G double prime sign change.
There it is, yep, sign change. And in our graph, that means we're looking for an f prime sign change. All right, so where does f prime have a sign change? Where is the slope changing? This is a positive to a negative, so it changes right there. It goes from a negative to a negative, so that's not an inflection point there. It goes from a negative to a positive, that is an inflection point right there. So the inflection point at x equals 2 and x equals 5. 2 and 5. And our rationale, I don't know what I'm doing there, is because g double prime sign change.
Mr. Sindel, if we were looking at the concavity, if that was like in that situation,
Yes.
wouldn't it be the same IP points?
So yeah, IP does separate where concavity changes.
So like it wouldn't be 5 and 2 and 5?
So if you're looking,
But if it wasn't, like in the situation where we were looking at concavity, like actual concavity, like where the...
It was where it went from up to down in that little.
Oh,
point
in the
between.
middle part. Okay, never mind. Thank you.
yeah, perfect. Thank you, Joy. Perfect. That is 10.5, and yeah, let's work on 10.6, the back side of that page. And on to self-check 10.6. So compute g of 4 and g of negative 2. So g of, I don't know, I was about to do negative 2 there. G of 4, that means I'm plugging in 4. This is going to be the integral between 1 and 4 of f of t dt. So I need to find the area between 1 and 4. So between 1 and 4.
That was a good line, Mr. Sindel.
Okay, I'll try it.
I'm sorry.
I can do this.
It's okay. It's okay, Mr. Sindel.
There, that's a little bit better. And then separate these into shapes. So this is going to be a 1 by 1. This is going to be a 1, 2, 3 by 1. So it's going to be 1.5 there. That's going to be 0.5 there. And that's going to be negative 0.5 there. And I know we're eventually going to need to calculate that area over there. It's going to be a 3 by 4, which is 12, divided by 2, which is 6. So we have the areas of all these. From 1 to 4, though, I'm going to calculate 1.5 plus 1. Plus 0.5 minus 0.5. These two will cancel each other out, so I don't need to worry about adding those. And I get 2.5. All right, oh wait, forgot g of negative 2. There it is. G of negative 2. Now, this is going to be the integral between 1 and negative 2 of f of t dt. But again, I want to flip that around, so this is going to be turned into...
Isn't the area of the triangle 8, not 6?
1, 2, 3 by 1, 2, 3, 4. So 3 by 4 is 12, and then divide by 2. I think it's 6. Yeah. It looks like it's 4 by 4, but it's
Oh.
okay. So this is going to be from 1 to negative 2 turns into a negative integral between negative 2 and 1 of f of t dt, and that is going to be, well, the area is 6 there, so it's going to be a negative 6. So we have those two. Okay, now we need to find instantaneous rate of change of g. This thing right here translates into g prime. Instantaneous rate of g prime at x equals 1 means g prime of 1. That means we're looking for g prime. G prime is the same thing as f of x, so this is really just f of 1. What is the height at 1? The height at 1 is 4. Absolute minimum. Whenever you see the word absolute, you need to make a table. If you ever see relative, then you can just find where it changes from negative positive or positive negative for sign change.
And it's all of them for relative?
All of them for relative, yep. Absolute, we're finding just the one. So let's make a table of x's. So our start point and end point, negative 2 and 4. Do I need... negative 2 and 4, and then I need to find all CVs. CVs is going to be where G prime is equal to 0, or DNE. G prime is equal to 0 where F is equal to 0. F is equal to 0 at this point. It crosses the x-axis, so we just needed 3 here. And then I need to find the integral for all of these. This is going to be... I'm going to skip a step here. It's going to be the negative integral. It would have been from 1 to x, so now it's going to be from 1 to negative 2, from negative 2 to 1 of f of t dt. Skipped a step by switching the bounds and making this negative. This is going to be the integral between 1 and 3, and this one is going to be integral between 1 and 4. All of these are f of t dt. F of t dt. All right, so between negative 2 and 1, we calculated that already. That's going to be negative 6. Between 1 and 3, we haven't done that one yet. That's going to be 1 plus 1.5 plus 0.5, so that's going to be 2 there, so 3. And between 1 and 4, so I'm just going to subtract 0.5 from this. It's 2.5. I'm looking for the minimum, so the smallest one is negative 6. And to make sure we have all the information, we say that the absolute minimum is negative 6. And where does that happen?
At x equals negative 2.
Perfect. At x equals negative 2. Thank you, Sophia. And yeah, we have that one done. Then we go on to the next part. So finding all these. So g of 3. So g of 3, notice that it gave us a graph of g prime, so we need to go backwards. And we have a start condition here. So the start condition is 5, so it's going to be 5 plus the integral from...
F of t?
Okay, so the time is 0.
Oh, sorry.
Yeah, so from 0 to that number 3. So from 0 to 3 of f prime of x dx. Oh, that's our 5-minute warning.
F prime?
It has... Sorry, it's not f prime. What should it be? It should be g prime of x dx.
Oh, even worse. Okay.
Because it's giving us a graph of g.
Okay.
G prime.
So why wouldn't it be negative 7?
Why are you not starting at position negative 7 for down here?
Uh-huh.
So the reason is because this is your start value. You always are going to start wherever it gives you the start x value. Your start x is 0, your start y is 5.
Okay.
Yep, good question. Yeah, whenever you have start information, that's going to affect that part right there. All right, so when you do this, the calculation is going to be 5 plus, and then this integral from 0 to 3. Okay, so we need to calculate all these shapes. So this is a circle, radius of 2, so pi r squared. 2 squared is 4 pi. So each of these 4 parts of the circle would be pi, which just means this one segment is pi, that other segment is pi. We need to divide this in half, or no, in pieces, I guess. So this is a 1 by 3, so it's a 1.5 area triangle there. So we need to do between 0 and 3, so from 0 to 3, we're adding those 2 pieces, and we have pi and 1.5, pi plus 1.5, to get a final answer of 6.5 plus pi. Moving on to g of negative 2, slightly more difficult because we have to go backwards a little bit. So our initial condition is 5, and we need to do plus. I'm going to skip a step here. So it would normally be integral between 0 and negative 2, but I'm going to switch these 2 around. So it's going to be integral between negative 2 and 0, and I'm going to make that a negative now, of our g prime of x dx. All right, so between negative 2 and 0, that's between here and here. That's just pi, and it's going to be a negative pi now. So it's going to be equal to 5 minus pi. And there's our answer. That is self-check 10.5 and
Can we say
10.6.
goodbye?
Okay.
Bye, guys. I miss you. You better kill Colville, not literally.
Yeah, good luck.
Bye.